Awesome. All right, we are live. Let me just go ahead and start recording here, and then we can get this show on the road. So welcome, everybody. Got a great meetup coming here in just a couple minutes. Let me go ahead and start our recording. Great. Just in case anybody is curious, we are recording this two ways. So, and we'll talk about that in just a second. My name is Robert Hodges. I'd like to welcome you to the April virtual meetup for the the San Francisco Bay Area ClickHouse Community Meetup. We are the oldest meetup in the United States. We've been talking about ClickHouse for at least 5 years. It's been going on for a while. We try to do these meetups every 2 months. We have a great set of speakers here today. Let me do a quick screen share if you haven't seen the agenda. They're going to, should pop up in a second here. Great. Okay, I can see the share. So we're going to have Delitso Banda of Sentry talking about schema management. At Sentry, they've been using ClickHouse for years, have some really interesting experience running at scale. My colleague Kanti Subramanian will be talking about replication from Postgres and Mongo into ClickHouse. And then our final talk, but not least by far, is Rohan Pednekar is going to do a cool discussion and demo of talking to ClickHouse from Presto, which is kind of a cool subject and something that if you haven't seen it before, it's definitely very cool. Just a little bit about this meetup. As I said, we're bi-monthly. Our next meetup is scheduled for June. We don't have the date set yet because we are looking to do something in person. We have been running these meetups virtually ever since COVID started, but it's time to get back, join the team or join all the enthusiasts. So we're looking for a venue to run this probably late June. So if you have locations that you might want to volunteer, in fact, anywhere in the Bay Area will do just fine. But we'd love to hear from you and see if we can get something set up at your place and bring a bunch of people in and geek out about ClickHouse. We're always looking for talks, and so if you have interesting experiences on ClickHouse, a new project to share, something really cool that you've done, want to teach people about how to do something in ClickHouse, these are the kinds of things that we do here. This is geeks only. We don't do marketing. It's just come in and learn how to use this wonderful database together. This talk is recorded two ways. We're streaming to YouTube. That's normally what we publish afterwards, so you can always go back and find this talk. I will do a short blog article within the next few days that also summarizes the talk, gives you links into the beginning of each talk. And folks who are presenting, if you could send me your slides, I will also include those in the blog article. I think that's it. So for those of you that are there, if there's anybody who'd like to jump in and say anything, introduce yourselves. This is pretty informal, so give you a second here. I'm gonna go ahead and unmute folks. If you want to just step up and say hi, we'll do that, and then we'll get going.
Hi guys, I am really excited to use ClickHouse. Looking forward for the second presentation about Mongo and Postgres. Thank you.
Okay, that's one vote for Kanti here. Anybody else want to just say hi and introduce themselves?
Well, hi, I'm David Zhao. I'm just starting working with ClickHouse. Basically, we're trying to making ClickHouse as the fast query database for our MySQL database. And I found Altinity's blogs and everything, videos are super, super helpful. I'm here just to learn.
Thank you.
Hey, hi, myself Suman. I have a good experience in MySQL and Postgres, so we would like to use the ClickHouse for analytics purpose. So I'm more interested in replicating from Postgres on Mongo to ClickHouse.
Cool.
Hey,
More intros?
Yeah, Jakob
yeah.
from Postcode over here. We've built some internal like schema management and migration tools as well. So curious to see what Sentry has done and what we can learn from it as well.
Score one for Delitza.
Hey, I'm Paul. I come from a heavy KDB Plus background, so really interested in ClickHouse. Just more here, just to learn more about the technology.
Excellent.
Oh, hi.
More folks. Yeah.
This is Don and Jad DeFonte here from Midpoint Markets. We're here to learn more about ClickHouse. We use it extensively already. We find numerous use cases where it does better work for us than the MySQL does. And we promise not to take too much time belaboring the one bug we'd really like you to fix.
Hey, what is that one bug, by the way?
Oh, we see a REST query has a certain
retool.
Sorry?
That's a retool bug.
Oh, I'm sorry. No, I take it back. It's not ClickHouse. Or is it Click? No, it's Retool.
We use retool to connect to ClickHouse, and there's no connector, so you have to do REST queries against ClickHouse, and it's really annoying. But it's not your problem.
It's not your fault. Sorry about that. So now we really won't waste your time.
Okay, well, that's good because we heard a lot about ClickHouse bugs over the last. It just happened that they came up in a couple of conversations. So
yeah, but
we're
we've
relieved that it's not us.
actually chatted before on the ClickHouse Slack channel, you and I.
Oh, great! Yeah,
I think I owe you an answer to a question from months ago.
cool. Yeah, and one thing I should just say very quickly, and then I'm going to turn it over to Delitzo. So my name once again is Robert. So I'm actually CEO of Altinity. I've been working on databases for about 40 years. Those are all my database books right behind me, if you can see the video. And I'm super interested in databases in general, ClickHouses in particular. For those of you who don't know us, we do sponsor this meetup. We're an enterprise provider for ClickHouse. I promise no marketing fluff, but if you do have deeper questions or want to run ClickHouse in the cloud on Kubernetes, come talk to us. So with that, I'm going to go ahead and stop my share and turn this over to Delitzo. And so take it away, and looking forward to this talk.
Yeah, thanks, Robert. Yeah, so hey everybody, my name is Delitzo. I'm a software engineer at Sentry, and today I'll be talking about ClickHouse schema migrations at Sentry. So what is Sentry? For those of you who don't know, Sentry is an application monitoring platform to monitor errors and optimize performance of code. So how it's used is if you install the Sentry SDK into your web app, for example, when exceptions are thrown and errors occur, they'll emit Sentry events and they'll get sent to Sentry and ingested in our ClickHouse database. And then you can do your aggregations and analytics queries on top of that on the Sentry dashboard. So we use ClickHouse a lot because it really supports our workloads of ingesting these large batches of events and then doing your analytics queries on top of that. So it really fits in well with our use cases. And just an overview of how we use ClickHouse at Sentry and our setup. We have right now maybe around like 80 nodes doing like 1,500 select queries per second, writing about 1 million rows per second, a payload of about 280 megabytes are written per second. We have many different clusters, but two of our main clusters are 5 replicas and 5 shards each. So I use ClickHouse pretty extensively at Sentry for kind of the base layer of storing a lot of our Sentry events. So today I'll be talking about migrations. I'll start with what migrations are, why they are needed, the challenges we faced building out migrations tooling, and then our solution that handles migrations at Sentry, how we make migrations run safely and how we make them scale. And then at the end, I'll cover some learnings that we encountered along the way. So what are migrations? In simple terms, migrations are simply changes to your schema or like your DDL statements. So these are statements that are different from your select and insert queries because they change the structure of your table. Examples here, the create table, alter table, drop table. So these DDL statements change the structure of your table, structure of your schema. So why would you need migrations? Why would you need to make those changes? Oh, there's a couple of reasons. I have a few listed here. One is product changes. At Sentry, we get like new features and new products added at Sentry. And typically, to support a new feature, we need to either add new columns to our database or create new tables. So that's one case. There's also a change in query patterns. So it's desirable to change the structure of your tables as like kind of the workloads change. Also, as you scale up, there's some things you may want to do, like add indexes to your tables to support scale as you grow with more data in your tables. And also, as you add upgrades and you change your infrastructure, it may also be desirable to change the structure of your tables to more closely align with the changes. But of course, migrations are hard and they are dangerous, right? If you run the wrong DDL statements, you run a drop table, you lose all your information. So there is this high risk in working with the migrations that you'll lose data and it's unrecoverable. It's gone from the database. Also, like just applying the wrong migrations that make your table structure not line up with your workloads can be very, very costly, can adversely affect performance. And also, if engineers who are writing queries for your database and are always aware of the changes, their queries will begin to fail because they are not aligned with the structure of your table. So migrations are very sensitive and care must be taken in doing them correctly. There's also a few extra challenges that we faced at Sentry. One is Sentry has many environments. So we're an open source company. We have our SaaS offering that many customers use, but then there's also self-hosted offerings where customers download our repos and run Sentry in their own local environments. Then there's also single tenant instances, which are a bit like SaaS, but kind of targeted towards one customer. So maybe a large company would want to run Sentry in this single tenant environment. So that causes some complexities because even though these different environments share a common code base, they're often different in configurations and different even in the ClickHouse versions they run. So there's some complexities in doing migrations there properly. We also have large high volume clusters at Sentry, and these are constantly ingesting data, constantly ingesting Sentry events. So there's kind of little room for downtime. As we do these migrations, we can't afford to like spin down all the clusters, apply these migrations, and then spin them back up. We have to do the migrations as quickly as we can, as efficiently as we can to ensure there's little downtime. And then there's also extra complexity with how we run these in a distributed environment. In Sentry's ClickHouse environment, we have some dedicated query nodes and dedicated storage nodes. And these are all running in a distributed fashion, so that introduces some complexity. So I'll look at how we kind of handled this in the past before kind of we fleshed out our migrations tooling. So the most basic way that we would do migrations in the past was, the manual approach. So this would be basically an engineer SSH into the ClickHouse VMs and executing these DDL statements. So we would have PRs with clients submitting their migrations, and then one of the engineers in our storage team would take in these migrations and log into the machines and run these DDL statements to apply the schema changes. But of course, there's several obvious issues with this. It doesn't scale, it's slow, it's not safe, and quite error prone. If there is maybe like copy paste errors as these statements are copied, or there is a typo, there's no like safeguards to really catch that. So high risk of errors happening with this approach, especially across many different nodes. There's also conflicts from ordering. So migrations are written in such a way many times that they should be run in a sequence. So you do something like create a table, add a column to it, and so on and so forth. So there is this sequence that have to be done, and there's these dependencies that can arise in these migrations, and this manual approach, it really doesn't properly respect that or have any safeguards to make sure the orders are followed. There's also poor observability with this approach. So as we have other Sentry developers writing queries for the tables, they need to know what state they are in. And so it's important that there is high observability into this to see what migrations have been applied, what the schemas are on the tables, and if there's any issues with running a migration, so that other engineers who are writing queries for these tables can write queries for tables in the correct state. So what we've been doing is creating what we call the Snooba migrations tooling. And this is a new way we're doing things at Sentry. So Snooba is this middle layer that sits in between Sentry's products, solutions, and our Kafka streams that send events, and our ClickHouse table. So our products and solutions and Kafka streams don't talk directly to ClickHouse. Instead, they go through this middleman that's called Snooba. And so we have built a migrations module inside Snooba. The goals with this migrations module that we're building are, one, to do migration safely, so have safeguards against errors, have it be scalable, so it could run clusters with like 100 nodes, and then also to have it observable so that clients who are writing queries for these tables know what state they are in and know what migrations have been applied and which ones haven't, especially across different environments. This is like a high-level overview of the tooling we came up with and the UI. So on the right, rather, we have the migrations table that keeps track of the state of each migration we run, shows if it's completed or pending. And we also have this blocking flag we introduce that lets us know if a migration is long running. So typically migrations that are like changing your sorting key would have the blocking flag set as true because they require rewrites to the whole table. And then on the left, we have a panel that allows you to select your migrations, and then you can execute dry runs of these migrations to see what the SQL is, and then allows you to also see dry runs of what reversing those migrations would be like. I'll go more in detail on this, but here's like kind of a quick demo of somebody using the tool. So you select your migrations, you can do a dry run to see the SQL and then execute your migration. We also have the functionality to run a backwards form of your migration. So the backwards pass kind of undoes what was done in the forwards pass in your migrations. And we give feedback to the user when their migrations have been run successfully. And I'll go a little bit more in detail about what's actually happening. So just an overview of the ClickHouse infrastructure at Sentry. We have two main classes of nodes. We have query nodes and storage nodes. Query nodes make use of ClickHouse distributed table engine. And so they do not store any data. Rather, they just reference data that's stored on the storage nodes. And we have our storage nodes have several replicas and shards. And so when your queries come through, first they hit the query nodes and then are passed through to the storage nodes. We have this scheme just because it's a lot easier to manage in practice. And so for safety of this migrations tooling, we added in a couple of abstractions. One is we don't allow you to work directly with your SQL DDL statements. Instead, we introduce this operator class abstraction over your SQL DDL. So for example, you'd have an operator for creating a table, an operator for adding a column, and so on and so forth. And then there's a migrations class, which is essentially a sequence of these operators. And each migration has a forward and reverse sequence. The forward sequence applies your migrations, and reverse is kind of like an undo sequence. So for example, if I have a migration to create the table and add a column, my forward sequence will have the create table operator and the add column operator. And my reverse sequence will have the drop table operator and the drop column operator and the drop table operator. And this is the hierarchy of these abstractions. We have a migration group, and in that migration group, there is migration IDs or migration steps. So each of those steps is a migrations class that has a sequence of operators, the forwards and backwards sequence. And then each of those operators gets compiled down to SQL DDL statements. So this is an example of a migration that's creating a table. So I have my migrations class here. And then I have defined the forwards and backwards sequences. So in my forward sequence here, I simply have the create table operator. And in my backward sequence, to undo it, I have the drop table operator that drops that table. I can also specify the blocking flag. So if it's a long-running, potentially high-risk migration, I'll set the blocking to true. Otherwise, I'll set it to false. So what happens behind the scenes is that migrations class, when it's time to run, will get compiled down to your SQL DDL. So in this case, the forwards operators get compiled down to create table, and backwards get compiled to drop table. In our repository, the scheme we use is each migration step has its own file with a prefix of its ID. It's a monotonically increasing ID and just like a brief description in the name. And that's how we're able to store the migrations. Then we also have a CLI tool that allows you to also more easily visualize like the state of your migration, see which migrations have been applied and what state they are in, and list them out. And zooming in more on the migrations tooling components. So one main component I talked about earlier is the migrations table. So the migrations table is responsible for keeping track of the state of each of your migration steps, such as the status, if it's been completed or it's not started or in progress, and also keeps track of the blocking flag on that migration step. And the other component is for executing the migration. So the panel allows you to select the migrations, run dry runs on those migrations to visualize the SQL and execute the migrations. And we give you feedback when your migrations run, and other features we added for observability, like Slack notifications, so that your whole team knows when your migrations have been run, what state the tables are in. I'll zoom in now a little bit more on the implementation. So I talked a bit about the abstractions, but if we zoom in closely on these abstractions, they give us a few extra benefits. One is this high order class for safety allows us to encapsulate migrations as a sequence of these operators, but also allows us more easily to capture dependencies so that we can input safeguards when these dependencies or ordering violations have occurred. So the obvious ordering violations are like trying to add a column to a table that hasn't been created yet. So in those instances, you want your migrations to run in kind of this logical order or chronological order, step by step in which they have been written. And so we have safeguards to check against that. But then there's also more subtle dependencies. One is if you're applying a drop, you need to apply the drop of a column on your distributed table first before you apply it to your local table first. Because if you drop a column from your local table first, your distributed tables will still be referencing that dropped column and you'll be getting errors in your queries. So some of these dependencies arise, and so we have a battery of tests in our CI and testing infrastructure to make sure that we capture these dependencies and send you alerts if they exist. This migrations class also allows us to do more things like classification, like we have the blocking flag we used to classify long-running and short migrations. We've also implemented access control lists, so we can set privileges for some migrations, so migrations that are deemed highly sensitive. We can set different levels and different users to run those migrations. Now I'll now talk a little bit more about how we make sure that this scales. So for scalability, we use the systems.clusters ClickHouse table to fetch the topology of the nodes inside the ClickHouse cluster. And then once we have that, we synchronously apply the migrations iteratively across the nodes. We do this synchronously to avoid race conditions and make sure that once we've applied migrations on one node, we're done with that node completely before we move on to the next node. So to help with this, we use the replications order partition syncs ClickHouse setting to make sure that when we execute statements, they are done synchronously. And because we're dealing with large clusters, there's always an increased risk of failures. And so to handle failures, we make use of the reverse functionality that we saw before. So when a failure is detected, we run this reverse function to undo the migration step that has failed. Another thing that we did was added in functionality to bootstrap new nodes. So when you add a node to cluster, we have this functionality to copy the state of migrations onto that node. So now I'll look at how this application of migrations runs through a simple walk through the algorithm. So you're beginning to apply migration. We have a dedicated migrations node that stores your migrations table, keep track of the state. You have an executor node that's running the migrations. The first thing it does is query the system's cluster table to get the topology, get all the nodes in the cluster. And then it sets the migration state to in progress from the migrations node. Then the executed node begins applying the migration step on all the nodes. And once it's done, it sets the migration state to complete. So this is a very simple algorithm that we used to apply the migrations. But of course, there's always the risk of failures. So what happens when there is a failure? When there's a failure, migrations for the step would be stuck in this in progress state. And so we know that a migration is incomplete when it's in that state. And so we can trigger running the reverse function on all the nodes to undo kind of what has been applied by that migration so far. But also has a caveat in that it introduces this constraint that reverse has to be idempotent because reverse could run on nodes that have yet to see that migration. So it's important that the reverse sequence has no side effects and is idempotent. We have some checks in to check that. One easy way to make sure that your DDLs are idempotent is by using the if exists clause, for example. So like if you have, let's say, a drop column DDL, if you add the if exists, you make sure that you only drop the column if it exists, and if it doesn't exist, you do nothing. So once reverse has been applied to all nodes successfully, then we can set the state back to node started, and it's as if that migration step never ran at all. So that gives us these all or nothing semantics for each migration step. There's of course some limitations with that. One is the migration table is this sort of single point of failure. And also we block on connectivity failure. If a node can't be reached, this algorithm wouldn't be able to make progress. We also found some special cases where the systems.clusters topology doesn't align with what we have in our config files. For example, one case that happened was when we were removing some nodes, we removed them from our config.xml ClickHouse settings file, but still had the nodes in Zookeeper. And so ClickHouse was trying to apply these DDLs on nodes in Zookeeper that it couldn't reach and that didn't exist. So we had a failure in that case. Another limit of this is it guarantees this all or nothing semantics for each migration step, but not for a migration group in general. So if you have a batch of several different migrations, we can't guarantee all or nothing semantics for that entire batch. Rather, we just guarantee it for the step. So what's next for the migration tooling? Next steps are to make this run more automated. So integrate this into our CI/CD pipeline so that as you merge in PRs into your code, the migrations get executed automatically. Then what we also want to work towards is improve observability across environments so that you can easily know what state your migrations are in across all these different environments we support. We had a few different learnings along the way. One major one was should avoid mixing ClickHouse versions if possible. So we ran into a whole bunch of different issues because we're using so many different versions of ClickHouse, and there's incompatibilities even across minor versions, and ClickHouse moves quite quickly in terms of development. And so it's desirable to have a consistent version and keep it relatively up to date, because when you mix in these versions, you end up in situations where you can apply migrations to some and you can't apply migrations to other nodes. So it gets pretty messy. Also learned it's better to break your migrations into baby steps, avoid doing too much work in each migration. Roll out the migrations in phases. That helps with backwards compatibility if something goes wrong. We also learned it's acceptable to have some degree of redundancy for backwards compatibility. So for example, if you are trying to write a migration that replaces column A with column B, instead of doing it in one step where you drop and add, you drop column A and add column B together in the same migration, maybe you could first add in column B in one migration, run the two column A and column B in parallel for a short while, then drop column A, and then continue using column B. So kind of these tricks help with backwards compatibility and improve safety. Another thing we learned is it's better to keep your migration changes in code separate from code changes in the rest of your repo. So if you're changing a migrations file, for example, the PR you have should only have those migrations changes and not changes in other pieces of your code. Yeah, so that's it for now. I'll take any questions real quickly if you have them.
That is a wonderful talk. Thank you so much. Here's one from Evan Hicks. How did you fix the problem where the system.clusters didn't line up with the configuration?
Yes, so we wrote a checker that runs before your migrations to detect all the inactive replicas, because that problem arose because Zookeeper had references to these nodes that had been already removed from the configurations files. So we wrote a checker that would run and make sure that these inactive replicas don't exist and warn you if they exist so that you can remove them before applying your migration. Yeah.
Okay, great. I hope that answered the question. Next one from Yako. How are blocking migrations handled differently from non-blocking ones?
Yeah, so blocking migrations are these sort of heavy migrations and are more sensitive and high risk. So for example, one thing we did is using our ACLs, give certain privileges to these blocking migrations. So only users who had some certain access rights could access these blocking migrations. Another thing is we don't run the blocking migrations in our automated pipelines just because they're high risk if something goes wrong. So having this classification allows us to do things like that. But in general, we found we can do away with running a lot of these blocking migrations in a dangerous way if we introduce some redundancy, as I described. So we use the approach where we would maybe introduce some redundancy where we'd be writing to two columns for a while or two versions of the tables for a while, and then do the switch over later. So kind of doing this approach of running dual writes for a while, then switching over later is a lot more safer than trying to run the whole migration at once. That's kind of rewriting the table, doing this long running step that's high risk. Yeah.
Great. Oh, there. Okay, this has got everybody pretty excited. Here's the next one. In practice, how often do you need to run the migrations? Like, is the schema managed constantly? And when running migrations, do you suffer any downtime or reduced availability?
Yeah, so in practice, I would say fairly often, maybe on the order of every maybe like 2 weeks or so. In practice, though, there is very little downtime because majority of the migrations you run are typically non-blocking. So they are doing things like adding columns or adding indexes, things that you can sort of do already in place. They don't involve table rewrites. But as I also described, in these migrations where we're changing something fundamental to the table, like changing the sorting key, I need to rewrite the whole table. We kind of avoid doing that and introduce some redundancy. So as I described, where you do the dual writes approach, so you're writing to 2 tables for a while, and then you do the switch over. So tricks like that allow you to have like no downtime, but still apply your migrations. The only downside is then your migration takes a bit of while to be applied. But we think that trade-off is reasonable, getting this safety, even though we're increasing the duration in which the migrations are applied.
Great. Final question in the current list. How have you handled very long migrations? For example, multi-week. Does the system handle failures automatically well, and does somebody keep an eye on it?
Yes. So the standard practice that we keep on seeing is the dual writes approach. Keep for these long migrations, keep redundancy. So maybe writing to 2 versions of the table. You keep that going for a while. That way it's low risk and you can monitor more closely. But even if something sort of goes wrong, you know that you always have it's backwards compatible. You can always fall back to the old version of your table. So that with that scheme, it's a lot safer. And for these long running migrations, you can leave them running for a while and not have to stress too much about it. The only instances where it sort of gets high risk is if there is like time crunch and you really, really need to switch over and apply that migration to switch over versions like real quick, and you don't have that buffer time to run dual writes for a while. But in practice, I don't think we've ever really hit that wall where we need to do a switch real quick. Usually we find running dual writes for a while is the easiest approach and very safe on our end.
Cool. I think that's questions from the crowd. I don't see any on YouTube. I have a question and a half that I want to bring up. So I noticed that Snuba is out on GitHub, and it has 256 stars, something like that. Is there anything that is really specific to Sentry that would prevent somebody from taking Snuba and using it in their own non-Sentry applications?
That's a good question. There is I'd say Snuba right now, we use it heavily for Sentry, and a lot of the design is around kind of Sentry's workloads. But I think the code is relatively well written and general enough that it can be used for other applications without too much difficulty. But they would have to be of kind of the nature of Sentry events. So time series, large batches of events being emitted and writing them to ClickHouse and running Kafka streams. But yeah, I do think it can be reused for a lot of other cases. Yeah.
Okay, great. And Snuba does a lot more than just schema management, it sounds like. When I look at because you've talked about specifically about this, but Snuba is also offers kind of a general data model.
Yeah.
Do you want to just comment a little bit about what the scope of the project is and how much of it you're currently using?
Yeah. So So the scope of Snuba is this model that does our communication with ClickHouse. So I would say Sentry events come in, or most of the information about events comes in through Kafka streams that we're running. And these streams want to get that information into ClickHouse, but we don't communicate directly with ClickHouse. Instead, everything goes through this intermediate module that's called Snuba. There's a lot of documentation on the Snuba page, but that's kind of the quick summary of it. And it has a whole bunch of different components. So there's components dealing with these Kafka streams and Kafka consumers that we're writing to ClickHouse. And then there's other components that allow you to query ClickHouse, so sending REST requests to Snuba's API, for example, to get information from ClickHouse, and other components that deal with type safety for your events and Kafka streams and that sort of thing. Yep.
Okay, great. One final question. This might be a bit off topic, but I noticed you separate the distributed tables and local tables to different nodes. What's the motivations? Excuse me. What's the motivation there? Is it mainly for easier migration or for optimizing performance?
I think the main motivation is management. It's a lot easier to scale up and scale down things when you have this sort of separation. You know, your the front end of your API has these query nodes and then the storage nodes, the back end. And so when you're trying to make adjustments, we found it a lot easier to work with this setup rather than kind of mixing storage and query nodes together.
Cool.
Yeah.
Okay. Thank you, Delitso. Thank you for a wonderful talk. This was really awesome. And I forwarded, there was a comment from the folks at Post Talk, very interested in what you're doing. Might want to look at it further together. If there's anybody else who wants to look at this, what I'll do is I'll go ahead. It sounds like if they want to talk to you, it sounds like the best way is maybe go to the Snuba project, post an issue, or somehow initiate communications there. What's the best way to get in contact?
Yeah, that would be a good way to get in contact. There is information on the Snuba repo,
yeah,
and you can post there. Yeah.
Great. Thank you so much. So I'd like to go ahead and queue up my colleague Kanti. He'll introduce himself and talk about replication from MongoDB and Postgres, two of our other favorite databases, and get us to move Rose into ClickHouse.
Hi guys, can you hear me?
Perfectly.
Okay, all right, I'm gonna share my screen 1 second. All right, put it in slideshow mode. Okay, yeah, so yeah, my name is Kanti. I'm a developer and a developer advocate at Altinity. I've been focusing mostly on the replication area, so kind of working on tools that'll bring data from different data sources, like MySQL, Postgres, and Mongo. So yeah, I'm going to be focusing on Postgres and Mongo. We've done talks in the past about replicating data from MySQL. So just a quick slide on why do you need the new tool. The perfect use case is say you have data sitting in different data stores, like transactional data stores, like MySQL and Postgres, and then you want to transfer that data into ClickHouse, your data warehouse, so that you can do analytics and then visualize the results on dashboards. So what are some of the existing ways is you can do a batch-based ETL solution using Airbyte, Airflow. There's tons of other tools. You can use Spark. But the problem is it won't be real time. It's not a solution. It's not a perfect solution if you're expecting to have a real time dashboard. There's also engines in ClickHouse. For example, the Mongo engine is is one option, but it doesn't let you run. It doesn't replicate inserts. It's more a read-only view of your Mongo database. Similarly, for Postgres, there's a materialized Postgres engine, which is actually much better, but it has limited detailed support. We'll get to detailed support in the later slides. The other tool or the other option is to use a Kafka sync connector. We actually developed a version of the Kafka sync connector, but one of the drawbacks is with the Kafka sync connector is you obviously need to run Kafka and the other services that come with Kafka, so that it might be difficult to operate and maintain that pipeline. So this is what we just open sourced it last week. It's in the same GitHub project as the sync connector. So it's the same project, but we kind of separated out into two separate folders. So what it does is it's a single executable. It's relatively lightweight because you don't have to run the other services. And currently we have support for MySQL, Postgres. We have a customer who tested MariaDB and MongoDB. So in terms of features, it's single executable. There's no dependencies. We support inserts, updates, and deletes as change data capture events. So if there's a change on your source database, it'll get replicated to ClickHouse. We have the features of auto create tables. So it kind of this feature kind of works differently for different databases. In MySQL, we actually parse the DDL because we get the DDL event and the DDL query. We wrote our own custom SQL parser, and so we have more support on MySQL. In Postgres, it's not the same as MySQL. We don't get the DDL event, but the way it works is if you do an alter table add column, you won't see the event right away, but then if you insert a new record with that additional column, we'll be able to figure out the changes, and then we'll do an add column on the ClickHouse side. We also have end-to-end monitoring using Grafana. So there's tons of examples on Docker Compose on how you can set up a Grafana dashboard and Prometheus and visualize your entire pipeline. Exactly one semantics. This is obviously very important because you don't want to introduce duplicates into ClickHouse. Currently, the way that is implemented is the acknowledgement or the marker is updated. So for example, you read 10 records from your source database. The marker that kind of moves your pointer to the next record is only changed after your records are completely persisted into ClickHouse. So there's no way we'll reread the 10 records again, or there's no way we'll have missing records. So that's kind of critical in a lot of use cases. We use the Debezium library, just like the sync connector. So one of the things that Debezium does, Debezium is a project that's maintained by Red Hat. It's fairly popular. It's used by even Google Cloud products. One of the biggest benefits of Debezium is they support a wide range of databases. They support MySQL, Postgres, Cassandra, SQL Server, so in specifically for databases, for data types, the biggest benefit is they do the mapping of the different source databases into kind of an intermediate data type. And so on the ClickHouse side, we're not really spending a lot of time trying to map MySQL and Postgres into ClickHouse. We're kind of mapping from the intermediate data type into ClickHouse. but for DDL, we do have to do it. But for DML, it kind of makes our life easier. This is just a slide about the different extensions you have to set up for the different databases. For MySQL, you need to have binlog enabled, GTID enabled. For Postgres, we use, so Debezium uses the logical decoding feature, which doesn't really require any setup. In Postgres 15, it's automatically enabled. And there's also another plugin called Decoder Buffs, which is actually developed by Debezium, and it's recommended compared to the logical decoding. In MongoDB, we use the change streams feature that is developed by Mongo.
Hey, Kanti, just a quick note. You've got some questions piling up. Do you want to just take them run through the slides and then take them at the end?
Sure, yeah.
Okay, great. So for everybody keep posting the questions, we'll get them all at the end. Thank you.
Okay, so in terms of configuration, we're trying to make it even more easier. For now, the way it is, you'll have to provide the source database information, so your Postgres username, password, and then the databases that you want to replicate, and if you want to do whitelisting on the specific tables, you can use this configuration variable just to pull in that specific table. And then the ClickHouse destination information. And so for Mongo, very similar. Basically, it's called collections in Mongo. And then, so with there's two options here. Either you can start replicating after you start the tool, so that'll only bring in data after the tool is started, or there's something called the snapshot, which means it'll actually try to pull in data that resides in your database already. So, but that's not very advisable. We would suggest you try. So, for example, in Postgres, a PG dump and ClickHouse client, maybe to load it into ClickHouse. It's way faster than Debezium. Yeah, I think that's about it here. All right, I'm gonna show a quick demo. Let's start with Postgres. All right. So let's just make sure there's nothing running. Okay. So we have Docker Compose examples where it starts the replication tool Docker image and the Postgres and the ClickHouse Docker images. All right, so it's starting up. Okay, so we have Postgres and we have ClickHouse. So let me log into Postgres. So let's, so there's already seed data in the Docker images. So one of the tables is called protocol test. Let me quickly, actually show create table doesn't work in Postgres. Public dot protocol test. All right, so it's a fairly simple table on the Postgres side. I'm gonna log into ClickHouse. And use public. Okay, so yeah, we see all the 41 rows were replicated. Okay, so one thing we do is on the ClickHouse side is we create replicated so replacing merge tree engine, and then we populate these two additional columns, sign and the version column. So this is useful when we have deletes and updates. Let's just let me just run a quick insert and just do showcase speed. All right, so yeah, so I just inserted one row in Postgres, and that was inserted into ClickHouse fairly quick. I'm gonna do an alter, quickly add a column into Postgres. So as I said before, it doesn't get replicated because of limited DDL support in Postgres logical decoding engine. But then as soon as I think I have the wrong insert. Yeah. Let me add this or for and just add put the values into the new column. All right, so perfect. Yeah. So yeah, in the tool, we, as I mentioned before, we figured out that the data type has changed, and then we create a new alter table add column to add this newer column, and then we insert the data. And so that's how we see this row getting replicated. I'm gonna stop Postgres and just do a quick MongoDB demo. This is gonna die soon. Okay. All right, so hold on 1 second. Okay, I'm starting the Mongo containers. Okay, there is a problem with the MongoDB container. I'm gonna see if I can do a Docker compose just to make sure everything is removed. I'm gonna try one more time. Okay, I think it started now. Let's connect to Mongo. Okay, Mongo shell. Okay, so use project, show collections. So we're trying to replicate the items collection in the project database. Let's quickly check. So it's this is one record that was inserted part of the seed data. Let me quickly log into ClickHouse. ClickHouse client, show databases. Okay, we should see the project database and the tables. Select star from items. Okay. Yeah, so we have this row replicated. I'm gonna quickly try to insert another one and see if the replication works. All right, perfect. So yeah, that's about it. The demo. Let me quickly go back to my slides. All right. Yeah, so you can go to this link. It's called the ClickHouse Sync Connector. There's actually a page where, so yeah, so this is how it looks. There are setup instructions here for setting up MySQL, Postgres, and Mongo. And we do have Helm charts for Kubernetes. Yeah, so there's also examples on Docker Compose and how you can set up the configuration. In terms of roadmap, the next steps are we're going to try to support Cassandra, SQL Server, and Oracle because they're already supported by Debezium. Yeah, I think that's about it. Do reach out either directly. We have a Slack channel. It's called Altinity DB. So if you have any questions setting up this tool or ClickHouse in general, you can sign up and ask questions.
Kanti, thank you so much for a great talk. We have a number of questions. I'm just going to read them up. We've got read them off. We've got one from David Zhao. What is Altinity Replicator? Is there a link to documentation? Thanks. I think you covered that because you showed the GitHub project. Do you want to post that link maybe in the chat just so people can get to it easily?
Yeah, sure. I'm doing it right now.
Okay, great. Okay, by the way, is materialized, it says materialized view portrait. I think what this should say is materialized PostgreSQL in ClickHouse an experimental feature? And I think the answer on that is yes, correct?
Yes, and yeah, so the difference is there's no DDL support for now in materialized Postgres. We have DDL support to an extent.
Yeah. Yeah, and I think a key thing also is that's worth mentioning is this replication technique will work with any version of ClickHouse. So, well, within reason, where the target tables here are replacing merge tree. You know, so you don't have to get a particular version of ClickHouse to be able to use this. Here's a question from Paul. With CDC, how do frequent updates and deletes impact ClickHouse performance?
Yeah, we've had this issue with replacing merge tree. I think our experience and suggestion would be to make sure it's partitioned properly and the order by columns are selected properly. In that way, you can make sure the merging process doesn't affect the performance.
Yep. And actually, there's a related question here from Arson. What ClickHouse engines could be used for tables that are replicated from Mongo? Any limitations? And right now, it is replacing merge tree, but you can actually use others as well. Or can you, or do you depend on? Maybe you could comment on that. What changes are necessary to use other table types?
Yeah, currently we only support replacing merge tree, but I can get back to you on the other support.
Yeah, and you were just talking about that earlier today. You know, like whether we should add the add support for other table types. So Arson, if you're interested in that, feel free to to post on the project. Oh, okay, great. Here, let me post the link. The link is appearing in the chat for Zoom for folks out on. Oops, let me get this out to everyone. All right, so the project, you should have a project link in the chat. So we're definitely interested in, well, you're interested in feedback. I'm not actually working on this. So let's see, I've got got some more. Yes. So in Postgres, do we use wall level logical, or can it work also with a replica? I'm not quite getting that correct. Can you is there enough there in that question for you to answer that?
Yes, you should be able to connect to the replicas. So it's just not
Right,
the
yeah.
primary. I know the logical decoding has some limitations, but the decoder buffs, you should be able to connect to the replicas. But on that example we have right now, I do set the wall level to logical on the primary.
Cool. Okay. Good. So that's answered. Do you experience any, here's a question from Arson. Do you experience any performance issues with the Mongo change stream? And how many documents per second can be replicated?
We haven't done extensive performance testing on Mongo, but we're working on that. We'll have an answer soon.
Great. And one question for replication purpose: would you recommend merge tree or replicated merge tree type? David, if you want to qualify that question, here, let me see if I can unmute you. Just a second. David, I think you can unmute if you want to just chip in and explain what you were asking there.
Oh yeah, so basically I'm very interested in replicating from SQL to ClickHouse, and we're gonna have like fairly frequent replication. So I'm just wondering, there are gonna be a lot of deduplication we need to do, right? Mainly for this purpose, which is a better table type?
Yeah, so Kanti, do you want to comment on that? Do you understand the question there?
Sorry, is the question if it's if the recommended engine merge tree or replacing merge tree, or is it merge tree or so my replicated merge tree is used more when you have multiple nodes.
Okay, so I'm not running a cluster. I'm just a single node, and I understand the deduplication gonna have a performance hit, right? Because when ClickHouse is inserting the data, it doesn't really enforce the primary key, and so then we have to do some kind of deduplication in the end. I'm just wondering, is that merge tree is still a table engine is still the way to go, and then we probably just deduplicate at the end of the insertion?
Right. You would use a replacing merge tree and use make sure your unique column is listed in the order by field.
Yeah. It'll dedupe it automatically.
Oh, if I use the replaced merge tree, right?
There are some performance consequences to replacing merge tree. So, and I think Kanti, you mentioned this, you have to make sure that you get that your order by also includes additional column. So it dedupes based on your order by, but if your order by doesn't include, and so in the naive implementation, you just put in the key, that your unique key or primary key from your upstream database. But that's not enough for merge tree to do queries. You also need to have additional, like if you're multi-tenant or something like that, you'd have tenants and other things like user ID or something, all the way down to finally on the rightmost column, you'd have the unique key. So that's one thing you got to do. Another thing is you have to be a little bit careful about things bleeding across partitions, because you'll end up having to do the dedupe will happen automatically in background when ClickHouse merges, but you also have to run final on selects, which is if you're familiar with that feature, and there's a cost to doing that as well. So it all comes down to how you organize data in the replacing merge tree. We can give you advice on that. And in fact, Kanti, I think we need to produce a nice FAQ like on the blog describing how to organize those tables.
Oh, that'll be super. And then referring that to replacing merge tree, but I think this is a replicated merge tree or replacing merge tree.
Replicated merge tree means that if you insert a row into it, it'll automatically be replicated to other nodes that are replicas within the shard and the cluster.
And then we're talking replacing merge tree. Okay, I got
exactly
that.
replacing merge tree. It's a really great table type. Kanti, thank you so much for this talk. I think here.
Thank you so much.
You are so welcome. Kanti, there's one more question. How do you deal with the lists inside MongoDB documents? Do you flatten JSONs or store them as is? Is it configurable? I'll let you answer that. And Rohan, if you want to go ahead and do and set up your slides, we'll jump into your talk after this question is done.
Sure, yeah, no rush.
Sorry, yeah, currently it is flattened. It's not configurable, but we'll definitely add that as a feature.
Great. Thank you so much. This was a great talk. I think you're tied with Delitso for a number of questions. Rohan Pednikar from Ahana has been patiently waiting. You're on, man. Take it away.
All right. Thank you, everyone, for joining in. Let me get my screen shared. All right. Can you guys see my screen?
Yes.
Yes.
Awesome. Yeah. Thank you, everyone, again. And thanks for having me to talk about Presto and Presto ClickHouse connector at ClickHouse Meetup. Just quick introduction. My name is Rohan Pednikar. I'm a product manager here at Ahana, and I closely work with open source core Presto project and Presto users. We love to get feedback from Presto users and basically improve the Presto experience overall. Today, I will be talking about what is Presto, Presto's architecture use cases, and then ClickHouse connector that we have built for the Presto, and a quick demo how you can achieve query federation with a Presto and ClickHouse. So let's quickly understand the technology. What is a Presto? So if you look into Presto project, it's actually Presto DB, right? But in a traditional sense, Presto DB is not a database. It is a distributed MPP, a SQL, just a SQL query engine, which allows you essentially query the data in place. That's number one. And number two is it's a fully ANSI SQL compliant. So let's talk about these three things. What does that actually mean? So what that actually means is, hey, you are connecting with the Presto, but you have ability to query MySQL, Postgres, S3, Elasticsearch, right? Without actually having to move the data from any of these data sources to any other centralized data source. What that allows you is to do essentially get a quicker time to value in terms of being able to query those data sources, and not just that you have the ability to do a query in place, you have the ability to do in a federated query, which means is that, hey, I can join a data between MySQL, Redshift, I can join data between MySQL, Redshift, and S3, I can join data between S3, Elasticsearch, and so on. Right, so this is something that doesn't exist in most of the technologies today, right? So there are some data virtualization engines that exist today, but in terms of fully fledged support, agnostic to the cloud system, agnostic to the underlying data platform, it is only available through Presto. Okay, so so seeing is believing. We will do a demo and I will show you some of these examples as well. And the last point is ANSI SQL, which means that, hey, you don't have to really learn any different SQL, any different language to work with a Presto. Like unlike a Spark, you need to learn the Spark SQL, which is associated with it. So you don't have to learn any new language. If you know standard SQL, you can run a query with a Presto. And that's pretty much. So any questions so far on this slide before I move to next one? Again, Presto is an open source Linux Foundation project hosted under Linux Foundation, right? So you can check it out at github.com at prestodb. So moving to the next slide. So here is a quick overview of a Presto architecture. So Presto is a distributed system of coordinators and workers. Coordinators which are responsible for query planning, scheduling, checking workers' health, and etc. And then workers are responsible to perform actual work on across the data, different data sets, different partitions, different splits, all in memory. So you can connect Presto with any of the reporting tools which are shown here using standard JDBC or ODBC protocol. You can use notebooks like Jupyter, Apache, Zeppelin, etc. to analyze and access that data. On the bottom, you will see the data lakes like AWS S3, Hadoop, as well as a wide range of data sources, NoSQL databases, relational databases, streaming data sources like Kafka, caching systems like Redis, and other real-time data sources like Apache Pinot and Druid. And today we will be also talking about the ClickHouse and how you can query the ClickHouse data. So you basically, when you essentially run a query on these data sources underneath, right, Presto will abstract a query for you. For example, it will abstract your MySQL query and make it appropriate MySQL query call. And if you are getting into Hadoop, it will abstract and make those appropriate API calls. You actually write a SQL query, but it will take that SQL, translate into API calls for underlying those data sources by the help of connectors, and query that data, consolidate it. If you are doing federated query, it will actually join the data between these federated sources and consolidate those results and return back to the client. So that's a simple overview of a Presto. Moving on to the Presto use cases, right? Presto has widely variety of everything from interactive, ad hoc, reporting, dashboarding, and new data lakehouse analytics. That is where the Presto has built its reputation. Facebook, that is Meta, is one of an example. Build it is as a replacement for a Hive. And Presto is not getting Presto is now getting used for their advertising use case, like federated. And another use case is like federated querying across data sources is extremely popular as far as Presto is concerned. And then the evolving use case is essentially around ETL. The technologies such as Apache Iceberg, Hoodie, Delta Lake, etc., are very common, which is getting used with a Presto in your data lake house to achieve ACID transaction and the ETL part of it. Let's talk about Presto architecture in a little bit in more depth. So what makes Presto different, right? So as I spoke about multiple parallel processing architecture, I will go through that diagram later. But so the scalable architecture makes it fast and performance. Next is the pluggable connectors, which means that, hey, whether or not connector exists today, Presto provides the SPI functionality, which means that, hey, you can use the service provider interface, which is provided by Presto, and write the thrift compatible connector, and you have ability to do SQL querying on something that didn't really support SQL query. Right, and last but the least is the performance. I would like to qualify this as a price performance. Yes, Presto is a fast. Presto is linearly scalable, but what it really makes the value of Presto is essentially price performance for a customers. For a fraction of the price you pay for like services like Redshift, Snowflake, you have the ability to get the real business value, real time to value as far as your analytics is concerned. Okay, so let's divide the scalable architecture of a Presto. Presto does support distributed coordinators today, which means is that, hey, you will have a more than one coordinator available, so that coordinator fails, the other coordinator will be able to pick up the work. That's number one. And number two is Presto is linearly scalable with addition to the new workers. The way that happens is because of the segregation of storage and compute, right? The beauty is that already been proven at web scale, like petabytes of data at Facebook, Uber, ByteDance, that is TikTok, right? Twitter, LinkedIn, and so on. Moving a little bit in depth of the scalable architecture, just diving in a little bit more. So first and foremost, like I said, Presto is agnostic how the query is being made. You can use a JDBC, or you can use a Presto CLI, or you could use Python or any BI tool, etc. Essentially query the Presto. Now let's talk about right? And essentially what it happens is when the query gets submitted to the coordinator figure out the query plan based on the statistics that are available to it. Now let's talk about statistics a little bit more. So there are two sources of getting the statistics, right? It is in traditional databases, it can be simply go through the database meta store, get the database statistics and figure out how the query is, what is the plan for that given query. That's number one. But if in case of object store like S3, GCP, etc., what you really need is another meta store, something like Hive is essentially common in Hadoop, and Presto is essentially built off of originally developed in a Hadoop ecosystem. So it can go as a meta store with a Presto. To obtain columns and table level statistics and figured out the best plan and execute as far as the query is concerned. So essentially the coordinator will plan the query based on the topology and workload that exists, and break that query into splits, do the task allocation across those workers, so that each worker is given a portion of the query to execute, and then workers will then execute on that portion of the query, return the results. Then further Presto coordinator will consolidate those results and return back to the end client. And that's how the architecture of Presto is. And then you have at the right, you have a top corner, essentially any databases or stream of a storage. And those are essentially what we are talking about, the connectors interacting with the actual endpoints, consolidating the results and returning back to the workers. And then the connectors do the magic of translating the plan, what actually needs to be fetched through the endpoints. So this is kind of architecture of Presto, very simple kind of a distributed system architecture. Let's understand a few terms before we jump into connectors. Like when you, and again, right, when we go through the demo, we will understand this. The way the data access is being done is done through the connectors. When you actually define a connector, essentially it is done by defining an instance of a connector, and that will become what is called as a catalog. So catalog have a schema. Schemas have a tables, and the tables have a data. And essentially, when you write a query, you generally follow the catalog.schema.table format, right? Again, when we go to the demo, this will become very evident, and I will explain you how we will go through with that. So these are essentially namespaces, which allows you to isolate, hey, what is the table I'm accessing, right? Because the same table could exist in MySQL, same table could exist in Glue, same table could exist in ClickHouse, right? So I want to able to clearly specify what that table is I'm accessing, and the way you do is by defining like catalog.schema.tables. Moving to the next slide. Okay, so moving on, right? So we spoke about this pluggable connector. So it is basically the SPI that provides you the ability to create a connectors to talk to these various other data sources. So today we have around 30-ish connector you can see in this list. This is basically the Presto official public documents, and the one of the connector that we have today is the ClickHouse that we will be talking and doing a demo around it. So basically, right? So we basically with the one of them is like a ClickHouse connector, which means like you can use this connector to query ClickHouse tables from a Presto, and not just that, you have the ability to do the query in a place without actually moving the data from these data sources or to any other centralized data sources, as I said, you have the ability to do a federated query, which means you can run a federated query joining a table which is sitting in a glue as well as a table which is sitting in a ClickHouse and so. So let me know if you guys have any questions at this point before we jump into doing quicker demo.
I don't see any open questions. I'm just having a quick look.
Awesome.
Yep.
Awesome.
Good.
Cool. So let's do a quick demo. What I'm going to do is I'm going to share my whole screen where I have a Docker container running. So awesome. So here is my basically Docker containers where I have Presto cluster running. So if you see, I have one coordinator and 2 workers running today for the demo purpose. And let's go and understand how I have configured connectors like today. So let's go and let's go to terminal. Okay, so this is one of my node on which Presto is running. And if you can see, the way we defined or configured connectors is we create ClickHouse.property or glue or dot properties or connector name dot properties. Basically, this acts as your catalog within that for that given connector and for that given that data source itself. So I have a couple of catalogs up here. I mean, connectors I have configured, and one of them is ClickHouse and Glue, which we'll be using today. So let's do one thing. Let's try to enter into Presto CLI. This is basically the Presto client. One of like you get it out of a box through when you install a Presto. And let's understand what all catalogs I have configured with my Presto cluster. So you just run show catalogs. So you can see, right, I have the similar catalogs here, the way I was showing in that configuration file path. Like I have a ClickHouse, Glue, JMX, memory system, TPCDS, and TPCH. These last 4 they are like by default comes with a setup. The Glue and ClickHouse is something that I have scheduled for today's demo purpose. Now let's understand what schemas I got within the Glue catalog. So you can see I have a schema called hoodie, some JSON files, NYC taxi data, PQ, basically the Parquet files, Parquet tables, sales data, sample, and so on. Now let's see what I got within, what all tables I got within catalog Glue and schema PQ, and you can see, hey, I have a hoodie customer table, transaction, Rachel. These are kind of some of the tables I already exist today. And now let's kind of run quick aggregation of aggregated query to understand, hey, what is the total of a transaction order by categories for you can see how much you have spent on travel, grocery, and so on. So this is kind of just trying right now. We are just running a SQL query on a data which exists in S3, right? So now let's try to understand what's there in my ClickHouse. My ClickHouse catalog. So if I do show schemas from ClickHouse. So like you can see, hey, I have a schema called Ahana default, and these are some by default that gets populated as you set up a connector. And I would like to share some ClickHouse instance that I'm using here as well. If we go back to the, if we do a ClickHouse here and see how you set up basically ClickHouse connector, you just provide a ClickHouse connector name. This will act as your catalog, which is getting reflected up here in the, in the client. And then you just defined with provide your JDBC URL, which is your endpoint. And Robert was very generous to provide me his ClickHouse instance. And this is how you can provide the password and user credentials up here. And then there is also a setup that you need to do, especially for a ClickHouse, to map your strings as a varchar, right? So this is very simple. This way you can set up your ClickHouse connector. And that's how it reflects in your client. So now we know, so we have these many schemas within my ClickHouse catalog. Now let's run a quick query to understand, hey, what all tables I got. So let's do show tables from ClickHouse, Ahana, and then let's see what I see here. Okay, so I have a table called customer. I have a table called SQL Squirrel synthesis, right? I have, let's see what else we got in default. What are the tables we have in a default schema? So here you can see we got, right, so we have an airport related data. So now I can understand, hey, I know now that, hey, there are these tables in a ClickHouse that I can run through, Presto. Now let's quickly run. The last part of the demo is the achieving the federation. Oops. So let's go to the slide. Sorry. Let me go do one by one. Okay, so here is my kind of a query that I have, like I have a table sitting in a default schema called airports, and there is other airports related information in my S3, and I'm trying to join this table using like ITA numbers and ITA code from this table and trying to achieve like a query federation. So let's run this query and see if I can, join these two tables together. Let's go back to the SQL. Let's run. Let's see. So for some reason, it is not allowing me to do. Let's get rid of the limits. What I have here is, I think because I'm using this super public demo account, which has very limited access, but I have ran the similar query before, and let me show you. Okay, here you go. So if you see this query that I ran, I was just doing a dry run of a demo, and you can see that I'm trying to join name. I'm trying to join airports table from my ClickHouse instance, and I'm trying to join other airports table from Glue database, like Glue AWS Glue catalog on this ITA and ITA code, and this is kind of query federation I have achieved up here. For the same reason, I'm facing authorization issues now, but there you go. Here you have it. And
yeah, Rohit, my apologies. This almost looks like a ClickHouse bug.
Yeah,
So,
no, you're good. I think
yeah.
I think it's very random. It's super random at this point. We may get a result as well. You never know. So
this we'll check this out. I noticed that for people who are looking, that's the 23.3 LTS build.
Okay, that could be the reason.
We do know this is a very fresh build, so still hasn't undergone a huge amount of testing. We'll definitely be looking into this. I don't believe it's a problem with Altinity.cloud, which is where you're running.
Yeah, no worries. But this is very simple. Like if you go back to my configuration up here, you just need a very few, free information to set up, like your endpoint, connection username, password, and that's pretty much. And this way you can achieve federation. So with that, I will open up. If you guys have any question.
I don't see too many open questions right now, but I got a question for you.
Yeah.
So how do you
Yeah.
So have you had any requests for people for ClickHouse access? How have you, in other words, have you seen much uptake on this? Because this is something I think you put in a couple of years ago. It's been around for a
Right.
while.
Good question. Right. So we do not have a lot of user using ClickHouse connectors. As you can see, we have a lot of connectors as well.
Yeah.
But the top three, if you ask the connectors that are famous today, are like Delta Lake, Hoodie, and Iceberg, and then Hive connector, which is one of the
Yeah.
top connectors. And like rest of them are like I would say 10% popular. People are only using mostly achieving the federation when they do not want to move their data around. Um, yeah, but now it is getting also a little bit of a popular when people only want to use one SQL standard, which is SQL is allowing to achieve them. So they are using ClickHouse for the real time analytics. They are using Spark for data ingestion and running their batch processing, and they are using Apache Hoodie, Apache Iceberg, or Delta Lake to achieve ACID and that data management thing like CDC pipelines. And then they are using Presto as only SQL unified, SQL kind of a query engine to run queries so that they don't have to move. Mostly what we are seeing is most of the data is moving into the cloud so that you can have a small data lakes within a cloud and run Presto to query it, and also have other engines as far as, because every engine has their own merits, right? So that's pretty much it is. I'm seeing what is happening in a Presto project.
Great. If people want to know more about this, Rohan and I did a talk last month
Yeah.
about, comparing, sort of data lake versus real-time analytics. I've just posted the link to it. Please check that out, because this is a really interesting, is a really interesting new area of combining the real-time analytics with these things,
Yeah.
like the data that's out on Delta Lake.
Yeah.
And so,
And just to summarize about the Presto project itself, you can reach out to me. You can find me at PrestoDB Slack, and you can also find other contributors and Presto committers up there. Also, you can find a lot of information about Presto at prestodb.io. We also do monthly meetups where you can find us, and we will see how Presto is getting used. And you can find us on a GitHub. Another interesting thing about the Presto project is Presto Day is coming up, like PrestoCon, which is annual Presto conference, which is super virtual, free. Anyone can join. So please go ahead and register for a PrestoCon day where you will learn a lot of good things about Presto, like Meta, Uber, ByteDance, that is TikTok, Adobe will be talking about how they are using Presto for their all kind of use cases. So with that, thank you so much for having me, and it was great, and it was a pleasure talking to you guys today.
Thank you, Rohan. And Dalitso, thank you so much for presenting. Kanti, we'll open it up for any general questions. We've got a few more minutes, but anything that you want to talk about on ClickHouse, we're here to geek out with you and give you an answer. It might be correct, it might not be correct. But yeah, open the floor. Any other questions? And feel free if you want to if you want to just talk, I can, I think everybody is able to, actually able to unmute and pose questions. So open it up. Or you guys can go have another cup of coffee.
I just have one question. Do
Yeah.
you guys see a lot of data ingestion, real-time data ingestion use cases around ClickHouse, or is just mostly real-time analytics?
Can you say real-time? Oh, real-time data ingestion. Oh, absolutely.
Yeah.
But it's kind of a
Okay.
niche. So one
I
of the
see.
things I know, I think Don, was it Don who was mentioning KDB Plus? I know we had at least one person who mentioned it. In the financial services, as well as anything where you have a market, one of the uses of ClickHouse is not to drive trades because they tend to be too fast, but to do things like generate metadata for the trading systems. So for example, you might have something that values securities, or values that, like if you're doing real-time ad bidding, in some sense values the assets so that they can be used for other systems. The closed loop on that, one of our financial services customers said the closed loop on that is about 500 milliseconds. So they try and ingest the data and be able to spit out new calculations of metadata to feed trading systems in about half a second. It's a niche. Most people are good if they hear what's going on within a few minutes.
Got it. Okay, thank you.
So good. I don't see any more questions popping up. So I want to thank the speakers. This is a wonderful set of presentations today. I think the best we've had in a while. So really diverse set. Thank you so much. You're all invited back anytime you want to come and do a talk. We'll get together in a couple months. For those of you in the Bay Area, we're looking to do something in person. Let me know if you've got a venue. Love to meet you all in person and geek out on ClickHouse. So thanks, and we'll call it a day. Talk to you soon, everybody.
Thank you, everyone.
All right,
Thank
bye-bye.
you, guys. It was really useful. Thank you.